amongst our graphing examples, here's the first one we're going to look at. And for this one, there are many, many, many possible graphs that satisfy all of these conditions. We're going to draw one possible example. First, we've got to get through what this information tells us, and then we're going to start working on the graph. So first off, this first row, we have f of 0 equal f prime of 0 equal f prime of 2 equal f prime of 4 equal f prime of 6. All of those are equal to 0. Now, one of those, f of 0 equals 0, tells us we get a point on the graph. So we have f of 0 equals 0, and that point is 0, 0. The other ones, f prime of 0, f prime of 2, f prime of 4, f prime of 6, all of those equal 0, tell us that our critical numbers are x equals 0, x equal 2, x equal 4, and x equals 6. Now, our next two lines here and here are about the first derivative. We have f prime of x greater than 0. That tells us when the function is increasing, and f prime of x less than 0 tells us when the function is decreasing. So we can say the function is increasing between 0 and 2, and then again between 4 and 6, and then decreasing where the derivative, first derivative is negative, between 2 and 4, and then from 6 to infinity. Okay? So we know something about one point on the function. Now we know about first derivative stuff. We know where critical points are, where the critical numbers are, and where increasing and decreasing. Our next two lines are about the second derivative. That's going to tell us about concave up and concave down. So concave up is when the second derivative is positive. So that's going to be 0 to 1, and then again from 3 to 5. And concave down, that's going to be when the second derivative is negative. That is between 1 and 3, and then 5 onward, so 5 to infinity. So we have some potential inflection points there when we switch from concave up to concave down, and then from concave down back to concave up, and then from concave up back to concave down. And then the last part we have is f of negative x equals f of x. That tells us that we're looking at the graph of an even function. And what really is important about that is that means it's symmetric across the y-axis. Okay, so we have all of this information to put together in a graph. And since this is symmetric across the y-axis, all of this information over here, you might have noticed we started at 0 and went onward from there. We're going to figure out how that works, and then we're just going to reflect the graph across the y-axis. And to do that, I'm going to put some things together. We're going to switch out boards for a second here and come back in a moment. Okay, so we know we have the point 0, 0, and for increasing and decreasing, I'm going to mark up the number line using our critical points, our critical numbers. And our critical numbers, we had x equals 0, 2, 4, and 6. So I'm going to put 2, 4, and 6. Now we know that the function is increasing between 0 and 2 because we know the first derivative is positive there. And then between 2 and 4, that will be decreasing because the first derivative is negative in there. Between 4 and 6, we're going to be increasing again. And that's because the first derivative is positive. And then from 6 onward, the function is decreasing because we have the first derivative is negative. So we can notice in here we have a local max right here at 2, a local min at 4, and then another local max at 6. And for concave up and concave down, we're we're going to break up the number line with the concavity intervals, and we had our potential inflection points at 1, 3, and 5. And the function is concave up between 0 and 1 because the second derivative is positive. So it looks like that. Between 1 and 3, the second derivative is negative, so the function is concave down. So like so. Between 3 and 5, the second derivative is positive, so that's concave up. And then 5 onward, we have concave down. Okay, so now we need to put all of this together. I have to switch boards again here. Sorry about that. Okay, and to put all of this together, I'm going to draw the number line again. Also going to remember we've got this point, and we know the graph is symmetric across the y-axis. But I'm going to put everything together on the number line with both the critical numbers and our potential points of inflection, because in some places we have concave up and increasing, some places we have concave down and increasing, and so forth. Okay, between 0 and 1, we had concave up and increasing, and so that means that the graph should have this kind of shape in here. Between 1 and 2, we're still increasing, but have switched to concave down, which means the graph should have this kind of shape. Between 2 and 3, now we have switched to decreasing, but we are still concave down, so we should have a shape that looks kind of like that. Between 3 and 4, the function is still decreasing, but now we have switched to concave up. So you should get something that looks, oops, not like that, that's increasing. So we want decreasing and concave up, so that looks like that. Between 4 and 5, now we have switched to increasing again, but we are still concave up. So we get something that looks like this. Between 5 and 6, we're still increasing, but now it's concave down. So we have increasing and concave down, so it looks like this, generally speaking. And then in our last segment from 6 onward, we are still concave down and we are now decreasing. So we're decreasing and concave down. So something that looks kind of like that. Okay, now remember this is just for one half of the graph. But we're ready to put all of this together on the graph. We know one point on the graph, that is the point 0, 0. Everything else we get to make up. We're going to start at 0, 0. I'm going to work on the right side and then reflect it across to the left. Okay, so we need to be increasing on concave up, so it needs to be something kind of like this. So we'll get something like so. And then we're going to switch to increasing and concave down. We want something that looks more like this. So 1 to 2. And then at 2, we know we have a local max, and we're going to switch to decreasing and concave down still. We're going to get something like this. And then at 3, we're going to switch to decreasing and concave up. So we get something like this. And I'm going to go ahead and just drop down like so. At 4, we get a local min, and we're going to switch to increasing but stay concave up. So here we go. Until we get to 5, where now we're going to be increasing and concave down, so it's got to do something like this. And then at 6, we have a local max, where now we're going to be decreasing and concave down, so we get something like this. And now all we have to do is reflect that across the y-axis to get what the other side of the graph looks like. So -1, -2, -3, -4, -5, -6. And it's gonna go something like, it's not gonna be perfect because I don't do this part very well. Perhaps you guys can do this better. But it will be something kind of like this. It should be a little bit higher here to match what we had on the other side. Like so. And again, there are many